Tons of scrap copper, twisted wires, burned cables, broken motors, discarded, forgotten, piled high. Inside this massive recycling plant, this copper won't stay wasted long, because in just a few hours, it will be melted, refined, and transformed into new electrical wires, clean, conductive, ready to carry power again, and it all begins right here. Every day, truckloads of scrap copper arrive from construction sites, factories, and old electrical systems. But not all copper is the same. Some is pure, some is mixed with insulation or other metals. So the first step is sorting. Workers and machines separate materials based on quality and composition, because the cleaner the input, the better the final product. Now the scrap moves to one of the most satisfying stages, wire stripping. Thick cables are fed into specialized machines. That slice through insulation, plastic peels away, revealing clean copper inside, bright, shiny, valuable. This step removes contamination early, improving efficiency downstream. Now the material is reduced further. Wires, motors, and copper components are fed into shredders. Rotating blades tear everything apart, breaking it into smaller pieces. The goal is simple: uniform size, better separation, from bulky scrap to controlled fragments. Now the mixture is sorted again. Magnets remove steel. Eddy current systems eject aluminum. What remains is copper-rich material, separated by physical properties. Because in recycling, precision means value. copper isn't alone. Plastic fragments, dust, residue, all must be removed. Air systems blow away lighter materials. Cyclones filter out fine particles, leaving behind cleaner copper feedstock, ready for the furnace. Now the transformation begins. The copper enters high-temperature furnaces. Heat rises beyond 1,000 degrees Celsius. The metal glows, then melts. From solid fragments to liquid copper, impurities separate, rising to the surface as slag. Removed carefully. What remains is molten copper. Flowing, powerful. Even molten copper needs refinement. Chemical adjustments are made to improve purity. Oxygen levels are controlled. Unwanted elements are reduced. Because for electrical use, purity is critical. This step ensures maximum conductivity.
The temperature is holding steady at 1500. Good, keep the flow consistent.
Now the molten copper is shaped. It flows into casting systems. forming long, continuous rods. Cooling begins immediately. The surface solidifies while the core stabilizes. From liquid to structured metal again. These rods are the foundation of new wires. Comes the most precise stage, wire drawing. Copper rods are pulled into a series of progressively smaller dies, stretching, thinning, refining. Each pass reduces diameter while increasing length until thick rods become thin wires, flexible, strong, highly conductive. This is where recycled copper becomes usable again. Freshly drawn wire is still warm. It must be cooled to stabilize its structure, then coated with protective layers, preventing oxidation, preparing it for real-world use. What was once discarded now carries power again. Old copper, reborn as new wires, connecting systems, powering lives, and every day, more scrap arrives, more metal is transformed. Because in this process, nothing is wasted, only renewed.